We have here some models of orbitals using Lux Blox. This would represent a s orbital, and this would represent 3 p orbitals, all intersecting orthogonally at 90-degree angles. Now, to talk about hybrid orbitals, what we can do is we can combine an s orbital with anywhere from 1 to 3 p orbitals, and we can get arrangements like this, which would represent 4 sp3 hybridized orbitals, or we could have an arrangement like this, where we would have 3 sp2 hybridized orbitals with 1 p orbital, kind of orthogonal to the orientation of that trigonal planar arrangement of sp2 hybridized orbitals. Or we could have this representation where this would represent the 2 sp orbitals, one here and one here, and then we'd have a p orbital here and a p orbital here, which looks a lot like 3 p orbitals, okay? But understand that this is 3 p orbitals, and this is 4 orbitals here, okay? 2 p orbitals and an sp orbital and an sp orbital. Now we can connect these orbitals together to represent bonding, okay? For example, this set of sp3 hybridized orbitals can combine with this s orbital representation here, and it would combine and we would form sort of a sigma bond here, where we have overlap between these electrons in these orbitals. Now, that would be a single bond. A single bond is just a sigma bond. For a double bond, what we would have was maybe a representation like this, where here I have sp2 hybridized orbitals, sp2 hybridized orbitals, and we have an overlap here in the sigma bond. But in a double bond, there's also p orbitals having a sideways overlap both above and below the sigma bond. And this region right here would represent a single pi bond. So I have a pi bond and a sigma bond in a double bond. Okay? So for a triple bond, for example, if I have here a representation where I have an sp orbital and an sp orbital overlapping to produce a sigma bond. But then what I also have here is sideways overlap of p orbitals above and below that sigma bond, producing a pi bond here. And then we also have, if I turn this, I have another pi bond here and here for the overlap of these p orbitals. So from end on, a triple bond actually looks as electron belts above and below and off to either side that sigma bond. So I have a sigma bond and 2 pi bonds in a triple bond. And finally, I want to show you this. This was an arrangement where I have 2 double bonds coming from the same atom. You could see this, for example, in carbon dioxide. And what we have here is an arrangement where we have sp2 hybridized orbitals here, sp2 hybridized orbitals here. You see how they're rotated by about 90 degrees with respect to each other. In between, we have sp hybridized orbitals here. And so what we have here is a double bond. We have a sigma bond and a pi bond oriented this way on this side. And on this side, we have another double bond. We have a sigma bond and a pi bond here like this. And you can see that they're sort of rotated by 90 degrees with respect to each other.